Hello! In this video we will talk about conditional probability and independence. This will be a short introductory video and we will continue to revisit these important concepts throughout the course. First though, I'd like to quickly review 3 rules of probability that we discussed in the previous video. 1. Probabilities must be a value between 0 and 1. 2. Probability of not A is 1 minus probability of A. 3. The probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Or in the case of mutually exclusive or disjoint events, the probability of A and B is 0, so the probability of A or B is simply the probability of A plus the probability of B. Okay, now let's talk about the concept of conditional probability. So suppose that I have some event A and I have some idea of the probability of event A. Then I obtain some new information about the event, right? In particular, I know that some event B has occurred and this event is somehow related to event A. So how can I update my probability of A given that I have this new information? In other words, what is the new probability of A given that event B has occurred? For example, suppose that you pick a random day and the probability that it will rain in that day is 0.35. Now suppose that you also learn that the random day you've chosen is a cloudy day. So the question would be, given the fact that it is cloudy, what is the probability that it will rain in that day? Given this, you would probably assume the updated probability would be larger than your original probability of 0.35. Let's look at another example to see how we can update probabilities in the face of additional information. Suppose I have 5 red cards and 5 black cards numbered from 1 to 5. If I pick 2 cards at random, what is the probability that I pick 2 red cards? How do I obtain this probability? Well, I could say that A is the event that the first card I pick is red and B is the event that the second card I pick is also red. Then the probability of picking 2 red cards is simply the probability of A and B. To determine the probability, I first need to figure out the probability of the first card being red, event A, which is just 5 out of 10, or 0.5. Suppose I choose this card, so it cannot be picked again. Then, from the 9 remaining cards, I need to pick another card in the hopes that it is also red. From these 9 cards, only 4 of them are red. So the probability of event B given A is 4 out of 9 or about 44%. I can then multiply the probability of event A by the probability of event B given A, which is 2 over 9. The point I want to make here is that the probability of A and B is the probability of A times the probability of B given A. We can also use this the other way around. So the probability of A and B is also the probability of B times the probability of A given B. Lastly, we can rewrite the formula as the probability of A given B is the probability of A and B divided by the probability of B. This is the formula that is used most often when introducing the concept of conditional probability. The next topic is the concept of independence, which is also very important. Suppose I toss a coin and A is the event that the outcome is heads. Meanwhile, B is the event that it rains tomorrow. What is the probability that it rains tomorrow given that my coin landed on heads? You will probably notice that tomorrow's weather has nothing to do with the results of my coin toss. So in that case, the probability of B given A is just the probability of B. In other words, event A, which is the coin toss being heads, does not give any useful information about whether it will rain tomorrow or not. Therefore, we say that these 2 events are independent. 2 events are independent when they do not give information about one another. This also means that in this situation, the probability of A given B is just the probability of A. Let's go back to our formula we discussed earlier in this video, where the probability of A and B is the probability of A times the probability of B given A. Now, if 2 events are independent, then the probability of B given A is just the probability of B, right? So a very simple formula here is that the probability of A and B is equal to the probability of A times the probability of B if the 2 events are independent. To summarize, here are the rules that we discussed so far. 1. Probabilities must be values between 0 and 1. 2. The probability of not A is 1 minus the probability of A. 3. The probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Or, in the case of mutually exclusive or disjoint events, the probability of A and B is 0, so the probability of A or B is simply the probability of A plus the probability of B. In this video, we talked about conditional probability and how the probability of A given B is equal to the probability of A and B divided by the probability of B. Also, if two events are independent, then the probability of A and B is simply the probability of A times the probability of B. Again, if you have never had a course on probability and these videos seem a little fast to you, don't worry. We will use and revisit these concepts as we progress through the course. Thank you for watching.